Hello all, welcome to Code Hub. Today let us solve the Lead Codes Daily Challenge, and the problem is the maximum score from performing multiple operations. You are given in two integer arrays, nums and multipliers of size n and m. The nums length is n, and the multipliers length is m, where n is always greater than m. They have mentioned also. Okay, you begin with a score of 0. Score is initially 0, and you want to perform exactly m operations. We can perform exactly m operations. When we do m operations on the ith operation, it is one based indexing. Choose an integer x from either the start or the end of the array. From nums, we can pick either start or end of the array. Nums add multipliers of I into x. Multipliers or sum becomes, our score becomes multipliers of I star the either start or end. This is the options, either start or end. So remove x from the array nums, then return the maximum score after performing m operations. So we have to return the maximum score. Since it is asking optimal solution, this may not be greedy, because if we take a possible path from one point, this may not lead to optimal solution in future. So we cannot assure that it may give an optimal solution. So we have to take for all possible paths. This is the example given, 1 2 3. And what is the optimal solution for this is, if we take the end of this nums array 3, start the multipliers array is 3, so it will give us 9. And if we take after removing this 3, we will be having an array 1 2. Again we will take the end of the array 2 comma 2 into this multipliers array. We will get a 4, and we are left with 1 alone, and it is multiplied with the other element 1, and we will get 1, and its total score is 14. And this is the optimal solution that we get for this solution. If we have taken other path, that is, if we multiplied 3 with this 1, we may get a smallest score. So we have to go for all possibilities to explore. Since we need to explore all possibilities, obviously we tend to go for recursion. So we in recursion we may write a recursive solution, recurrence relation, such that is going to going to explore all possible solutions. So first we will tend to represent this multipliers array in terms of indexing. So since this multipliers array only want to be we have to do m operations, so we can have an index I which is going to go from 0 to m. So we will tend to write a recursive solution, that is this is my I is going to go from 0 to m. And I also, what all parameters I need to carry, I will carry nums and multipliers array. I hope and other parameters I should carry an other indexing for nums as well. So how we can do is, we have to pick either start or the end from this nums array. So we can have a start index and also an end index, which is going to have the index from the start and end in nums array. So what will be the recurrence relation? Let us try to write now the recurrence relation. There will be two options, either pick int, pick start. If I pick the start array, what will be the possibilities? I can go either multipliers. I have to multiply with this multipliers of I star. I am picking the start, so start is nothing but nums of start plus this next recursive solution. Since I am picking this start index, what will happen to my recursive solution? My solve I will become +1 and nums will be passed and multipliers is also passed, and then start will become +1, start +1 and end will be remaining the same. So this will be my first option. If I pick the end, what will happen to my recurrence relation? Multipliers of I start, nums of end, and solve I plus I will move to the next index, nums multipliers and start will be remaining at the same position and end will be decremented by 1. And finally I am returning this maximum option. So maximum of this pick start or pick end, that's it. So this will be my recurrence relation. Hope you understand. Let us write, this is my recursion code. Let us try to convert this logic into our code itself. So we will write this recursive solution solve. I am passing 0 initially and nums array multipliers and then start and the end is nothing but nums dot size -1, nums dot size -1. N is always going to be greater than or equal to m, so it should not make any conflicting in terms of accessing the index. So let us write the define the function int solve int I, and this are the parameters nums and multipliers, after which I also need a start and then end. So what will be my base case? The base case is if my I have to do confirm m operations, that is multipliers dot size number of operations. So if my I has reached multipliers dot size, then I will be returning 0. So this will be my base case. Okay. Or else what I can do is I can have two options. I can just write this, copy this and paste here. I have only two options. Either I can pick this start or I can pick this end. And finally I'm just returning this maximum of this pick and end. And any other base cases this needed? I hope since n is greater than or equal to m, this definitely the start and end is not going to matter at all. I will definitely do one operation and I will move to this next, which will reach the size of the multipliers array. So this should be fine. Let us try to run our code. But this is a recursive solution. It may be exponential time complexity because it may go up to 2 power m, because we are taking for each and every index we are going for we are exploring two options. So definitely this is going to give us TLE. Let us try to memorize it. For memorizing it, we have to see what are the parameters changing. Here we have three parameters changing. This I and then start and end. What are the size of this size this can grow? The start and end is nothing but the nums dot length. Nums dot length is growing till 10 power 5. So let us try, since there are three parameters changing, we have to declare a three-dimensional array vector int dp of size. I will get the size first, nums dot size and int m equal to multipliers dot size and nothing but n minus 1. Okay, now I have the vector of int dp. This size is I is nothing but the multipliers dot size. So m comma vector of vector int, this is of size, the second dimension is of size n comma vector of int, and the third dimension is also of size n. Initially it is -1, and I'm also passing this dp array. And copy paste this dp and pass it to our function. with ampersand, and if my dp of I start and end is not -1, if it is already if already solved, just return me that dp of I start and end, and pass this dp as well, that's it. We have done memoization, that's it. So here let us try to run our code now. Superb, it is getting accepted. Let us try to submit our code. This should work. It got memory limit exceeded since we are using a 3D 3 dimensional array, right? So we got memory limit exceeded. So as you can see that why we get memory limit exceeded, it is a 3D array that we have declared, 3D DP array we have declared. So it is definitely going to be lot of memory taking, m cross n cross n. So how can we reduce this memory limit exceeded? Definitely we can reduce, because m and then we are using a n, where n we are having a 2D times. So n actually there is a start, and then end. So the start and end is going to be nothing but it is going to be range from 0 to n. So start we can name it as 0, and end we can, how we can do is, it is nothing but n minus start minus 1, right? So to reduce into a 2D DP, how we can change the parameters? It should be depending on I as well. So consider we have this left as the start. The start is going to be equal to this left index. Left is starting from 0, and I will use this left and I to represent this end. How I can do is, num start size n minus 1. I will get the 0 based indexing of size of num start size, and then minus I minus j will give me the index that I should take in the end. So that this 2 will just represent the start and end, so that I can reduce this 1D into a 3D into a 2D array, 2D DP. So now that solution will become m cross n, and the space complexity will also be m cross n. It is a 2D DP, so it will be reduced, and we get our answer accepted. Let us try to run. Let us try to change this first. So we don't want this extra parameter 0. It can start with 0, and then I will name this to be left, and this is only a vector of vector in 2D DP, and this start, it is not start, it is left. And what is end? End is nothing but n equal to nums dot size. How this end is nothing but the right side of this nums dot size array, end of that nums dot size array. How I can just represent n minus 1 minus of I minus j, I minus left. And here I will be moving, and the start and end, left will not be moving, left will be staying at the state, and here in this option left will be moving by 1 position. So finally I will memorize it with I left, and even here I will memorize it as I left. that's it. I don't want this end also. Now we can let us try to run our code and see whether it is getting accepted. It is getting accepted. Let us try to submit our code. We get 90 limit exceeded. Super. We are getting time limit exceeded for our solution, for our recursive solution as well. It is well and good. It is challenging more. Okay, let us try. Let us try to do better solution even more. Okay, we have done recursion and then it showed memory limit exceeded since it was 3D DP, and then we have reduced it to 2D DP, and even more. Now we have to reduce the space complexity of recursion stack space. So how can we reduce the recursion stack space? If we reduce this recursion stack space, we want to go for the tabulation method. So let us go for tabulation method. We can first initialize this to be 0, and then what we can do is we can uh, see what are the parameters changing. The parameters changing is I is nothing but it is going from 0 to n, and there is a left pointer that is going from 0 to n. So now we have to in tabulation we have to write this in opposite fashion. We have to write this two for loops in opposite fashion. So for int I is equal to m minus 1, I greater than or equal to 0, I minus minus, and for int left equal to n minus 1, left greater than or equal to 0, left minus minus. So in this we have to write a recurrence relation. I'll just copy and paste this recurrence relation here. Let us take this solve and we can just write dp of I plus 1 left plus 1, and here it is nothing but solve is now we have to take and write dp of I plus 1 left, and finally my dp of I left is nothing but max of the start and big end, and finally I have to return dp of 0 comma 0, dp of 0 comma 0. Super. And this is what the tabulation method. Hope this is very easy since we have written the code for recursion and memoization. It is more easier to convert it into a tabulation. So let us try to run our code. Okay, we get some wrong answer. Let us see what is it. Okay. Oh, if there is an extra index, yeah, it should be an extra index because left plus 1, we are accessing our left plus 1 and right plus 1. So this should work fine. I think this n minus 1 is making the conflict because it should start from the ith option. It should not go from n minus 1. It should not come from n minus 1 repetitively. It should not calculate. It should come from I. So left starts from I. Yeah. Okay, let us try to run our code now. Why so? We saw that I was going from 0 to m, and left left was going from 0 to n, but we are calculating n minus 1 minus of I minus n. If it is n minus 1, it will take the first value, so we should not consider left to be n minus 1, so we should consider it as I, because there will be, yeah, always n is greater than or equal to m, so we may access an index which is outer of this multiplier star size. That's why we have kept this left initialized I. Let us try to run our code. But now we are getting a memory limit exceeder. What is this? What is wrong with this? Let us try to keep it as n plus 1, n plus 1. Mem set dp 0 size of b. What is wrong with it? Okay. Now let us try to run. Even now it is not coming. What is wrong with this? I think it is the accessing the index only a problem. Let us try to give the maximum value of this index, so that we don't want to access a smaller access an index which is not in the size of the array. What we can give the size of the index to be in power 5, right? In power 5 we can give like this. At least this should be accepted. That's the final thing that we can be doing. Let us try to do it. And I think it will get memory limit exceeder. Let us try to reduce that as well if it is not getting run. It is not running at all. Let us try to let us unknown pre-process compiler. Even now it is something runtime error. What is happening here? Okay. N minus 1, 2, 3, 4, 5. Unable to execute the command. Plus 1, plus 1, we can try all the possible combinations and see where the other it should get accepted, right? Okay, it is getting accepted here. Why it is not accepting for n plus 1? And even for m plus 1 and m plus 1 it is getting accepted. Maybe the size, minimum size of the array, right? Maybe that may be a case. Okay, let us try to submit it. And finally we got submitted. Okay, hope you liked this video. I will give a small dry run. We have done the recursion and then the memorization, after which only we came to this tabulation. So then only you can understand why this tabulation is came. So hope you like the solution. If you but we have struggled a lot to come to this solution, but not an issue. It is all learning, right? So let me know in the comments if there are any suggestions. Let us meet in tomorrow's LeetCode Daily Challenge. Until then, bye.